Hi, so in this tutorial we're going to pick up where we left off on calculating relative velocities. The problems we're about to see are very similar to what we saw with the ocean, ship, bike, and muffin problem. But it's a slightly different approach in that we're not going to have layers of objects moving on top of each other, but rather moving objects relative to each other on the ground. And if we're in one vehicle, what does the speed of another vehicle, or I should say velocity, look like? So it's going to be the same general equation. It's just not as obvious how it's going to be applied. So I'll walk you through that. Okay, so let's look at the problem. So we have three vehicles, an Audi, a Chevy, and a Volvo shown below. And notice I've got arrows indicating their speeds and their directions. Okay, so I'm not going to read through all of them. You can read them yourselves. And so we can ask three questions here, A, B, and C. How fast is the Audi moving relative to the Volvo, then the Chevy to the Audi, and then the Volvo relative to the Chevy. So what I suggest you do now is pause the video and kind of make a hypothesis as what their relative velocities are. So for example, in the first one, I want to know how fast is the Audi moving relative to the other car. I want to make sure I know what frame of reference I'm in. So I'm looking for the velocity of, okay, I don't know why this is not working. All right, so I want the velocity of the Audi relative to the Volvo. So that's how I'm going to write it. Okay, then in this one, I want the velocity of the Chevy relative to the Audi, and then eventually the velocity of the Volvo relative to the Chevy. So in the first one, imagine you're in the Volvo. You're in this car right here. How fast does this car seem to be coming at you? Again, you can work this out conceptually and perhaps get the right answer, but we want to make sure you're doing this consistently right. Okay? So in order to do that, right, we're going to try to do our equations from before, okay? So to apply the equations from before, we want to realize when you're in any given car's frame of reference, they do the following. They do not see themselves moving, okay? So if I'm in the Audi, or excuse me, in the Volvo for the first problem, I don't see myself moving. I instead see the ground moving, okay? In other words, the velocity of the ground relative to the car, v ground relative to the car, is negative the velocity of the car relative to the ground. Okay? So when we go to do our equation of the velocity of one car, B, relative to another, we got to take into account how fast the ground is moving relative to the car you're in. So imagine just for right now, you're in a car moving down the road, you look out the front window, the windshield, you see the ground rolling underneath you at the same speed as your speedometer reads, just in the opposite direction. So what this equation becomes to do this is the VBA. I'm going to bookend the B and the A, and then between them is the ground. So it's going to be the velocity of the first car relative to the ground. That's my middle layer, the ground, plus the velocity of the ground relative to the second car. And if you set it up like this, then the problems become a little bit easier. So let's go ahead and do it for the problems that we saw above, and then I'll have you do your own practice. So if I want to do how fast is the Audi moving relative to the Volvo, so we're in the Volvo, I just set it up like below. Okay, I'm going to do VAG plus VGV. Again, the A and the V's are bookended and the G's in the middle. Okay, so let's put it in. So what's the velocity of the Audi relative to the ground? Well, that's this. We're going to say to the right is positive, so we're going to say 40, positive 40. Now, the plus, now I'm going to ask what's the velocity of ground relative to the Volvo? So here's the Volvo. This 10 is equal to the velocity of the Volvo relative to the ground. Let's assume these velocities coming, someone is standing on the ground. So therefore, the velocity of the ground relative to the Volvo would simply be the opposite of that. So if this is negative 10 because it's to the left, then we're going to make the negative a negative positive. So it's going to be plus 10, and we get 50. And it's a positive, and so 50 means, in this case, east. So I could say this is 50 east. In other words, if you're in the Volvo, the Audi is coming at you at 40 plus what the ground seems to be coming at the Volvo, which is 10. So in that case, a head-on collision is much more violent because the relative speeds are that much higher. Okay, so let's try the Chevy relative to the Audi. Okay, so let's erase all this. And what you know, once again, is the Chevy and the Audi are moving towards each other. Imagine those two velocities, those two cars are lined up, right? Even though they're kind of shown offset, that's not really the case. Okay, so I would just go through the process. This equals VC ground, using lowercase g, plus V ground A, excuse me. So the velocity of the Chevy relative to the ground is given to the left, negative 30, plus what's the ground relative to the Audi? So the Audi is moving this way, the ground seems to be moving that way, so that's negative, so plus a negative 40, and I get negative 70 meters per second, and negative means to the west. So if I'm in the Audi, right, the Chevy is going to seem to be approaching me this way, which makes sense, to the west, but at 70 miles per hour because they're moving towards each other. All right, and the last one is maybe the simplest. What's the Volvo relative to the Chevy? So the Volvo's here, the Chevy's here. They're both moving in the same direction. Since the Chevy's moving faster, it's going to seem like it's moving away from the Volvo towards the left, the west. So we should anticipate that. So that's going to be, okay, I'm not sure why I'm on that. All right, sorry about the delay. So the velocity of the Volvo relative to the Chevy, come on now, you can do it. Try that again. All right, not sure why it's misbehaving like that. All right, sorry I have to switch colors. It's a glitch with the recording program. So the velocity relative to the Chevy is VV ground plus V ground Chevy. In this case, the Volvo relative to the ground is negative 10, and the Chevy relative to the ground is negative 30, but we want ground relative to Chevy, so that's plus 30, and we get positive 20, which is 20 to the east. In other words, I'm sorry, I had it backwards when I said earlier. If you're in a Chevy, it's going to look like the Volvo is receding from you. It's moving to the east because it's going slower. If you're in a Volvo, the Chevy is going to seem to be going 20 to the west. Okay, so what I want you to do on your own is go ahead and, oh, we already did these. I'm sorry. I didn't realize I did them up. Okay, so we have those. Come to class with questions, but you can try these problems on your own in the homework.